So today we're talking about amplitude and period over sine functions. Sorry I'm not here, but you guys will be fine. So this is the activity that you have in front of you, and I'm just going to kind of walk through and discuss the answers to it so you can make sure that you understand. So first, period. We talked about period already. It's the distance between any two repeating points, or it's the distance it takes a function to complete one full cycle. And amplitude's the distance from the midpoint to the highest or the lowest point of the function. It's always a positive value. So it represents distance. Distance is always positive. So amplitude will always be a positive value. So I'm going to graph the sine function below. So remember, I know that the period for sine is 2 pi. So I'm going to take 2 pi, I'm going to divide it into 4 sections. And remember, when you take the period of 2 pi and divide it into 4 sections, you get your increments that you number by. So I know I'm going to number by pi over 2. So I'm going to have pi over 2, 2 pi over 2, which is pi, 3 pi over 2, 4 pi over 2, which is 2 pi, 5 pi over 2, 6 pi over 2, which is 3 pi. And then I've got all my negative values down here. Negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, negative 5 pi over 2, and negative 3 pi. And now if I think about my unit circle, I can fill in my points. At 0, sine has a value of 1. So I'm going to go ahead and make this equal 1. I'm sorry, that's wrong. Undo. At 0, sine has a value of 0. So make my point at 0. Pi over 2, sine equals 1. At pi, sine equals 0, and so on. You guys have graphed this a bunch already. This should look familiar. I'm going to connect with a smooth curve. Notice I'm not making like sharp points. Make my points here. Okay, here is sine. So what is the period for the sine? It's 2 pi or 360 degrees. So 2 pi radians or 360 degrees. So it's the amplitude. The amplitude is 1. The distance from the middle to the top is 1, or the middle to the bottom. Notice it's positive 1. Now we're going to graph cosine. So cosine, unlike sine, doesn't start at the origin. It starts at 1. So I have my same numberings here. 5 over 2, 2 pi, 5 pi over 2, 3 pi, and then we go into the negatives. Pi, negative 3 pi over 2, negative 2 pi, negative 5 pi over 2, and negative 3 pi. Now cosine starts at 1, so I'm going to make a dot at 1, and then it goes to 0, negative 1, 0, positive 1, 0, negative 1, and then it continues over here. Okay, and it makes a smooth curve. And notice I'm not making any jagged, like sharp tops, smooth curves. What's the period of the function cosine? Well, it's 2 radians, or 360 degrees, because notice it takes 2 pi radians to complete one full cycle of the graph. What's the amplitude? The amplitude is 1, again, because the distance from the middle to the top is 1. So let's look at how you change the amplitude of a function. So it says below we have the graph, y equals 3 cosine theta on this domain, negative 3 pi to positive 3 pi. What is the amplitude? Well, the amplitude, remember, is the distance from the middle to the bottom or the middle to the top. And here, that distance is 3. Okay, 1, 2, 3. So the amplitude is 3. What do you think the amplitude of this function is? 4. Explain. So here we did the distance from or midline to the bottom is 3. Here, I'm going to make the connection that I can see that this number that is in the front, this 3 here, represents the amplitude. So here we have a 4, so I'm assuming that the amplitude is going to be 4. So it's the number in front of the function. Okay, and it's being multiplied. So graph the function y equals 4 sine theta. Well, it's going to be the exact same thing as sine theta, except instead of going up to 4 and down, or sorry, up to 1 and down to negative 1, I'm going to go up to 4. So 1, 2, 3, 4, and down to negative 4. 1, 2, 3, negative 4. We're going to number by the exact same thing. So pi over 2, pi, 3 pi over 2, 2 pi, 5 pi over 2, 3 pi, then we've got our negatives, negative pi over 2, negative pi, negative 3 pi over 2, negative 2 pi, negative 5 pi over 2, and then negative 3 pi. So this is sines on the start of the origin. Go up to the top, which in this case is 4 because the amplitude's 4. And there's my graph. Down to negative 4. And notice the only thing that changed is that instead of going up to positive 1 and down to negative 1, it's up to positive 4 and down to negative 4. So write the equation of a cosine function with amplitude A equals 2. Well, I could have y equals 2 cosine theta. I could also have y equals negative 2 cosine theta. So all this negative here is doing is it's reflecting the function down across the x-axis. It still has an amplitude of positive 2. Remember, amplitude is distance, is always a positive number. So let's look here at number 9. What's the amplitude A? So amplitude 6. Amplitude here is positive 3. Remember, it's the absolute value. Here, amplitude is its absolute value of negative 3, which is 3. Its absolute value of negative 2, which is 2. And the amplitude here equals 25. Moving on. All right, changing the period of a function. So we just changed the amplitude, which is how high and how low the graph goes, and now we're going to change the period. Remember, the period is the distance it takes to complete one full cycle. So what's the period of the function y equals 2 cosine 2 theta? So here's the start, goes 0, down, back up to the top. Well, pi. And I know that because it took pi radians to complete one cycle. Okay, here is the graph of the function y equals sine of 4 theta. So if I think starts here, down, back to the middle, that's 1/2 pi. So the period is pi over 2. Period equals that. Period equals that. How did I find my answer? It took that many radians to complete the cycle. What is the period of this function? Well, what I'm noticing is that it's taking the normal period and it's dividing it by this number out front. So my normal period for cosine is 2 pi. Well, here, notice this is just 2 pi divided by 2. Okay, it's dividing by this 2. That's how we got pi here. Notice that this is just my normal period divided by this 4. That's how we got pi over 2. So on number 12, it's going to be my period, which is normally 2 pi, divided by the coefficient, which is 8. So my period is now pi over 4. How did we get that? Well, I just used the equation period equals 2 pi over k. And k is this value here. Okay, k is the value in front of theta. So graph this function sine 4 theta. Remember to find your increments by dividing the period into 4 parts, then label the axis. So I'm going to find my period. Period equals 2 pi over 4, which is pi over 2. Now my increments I get by taking my period, which is pi over 2, and dividing it into 4 parts. Well, dividing by 4 is the same thing as multiplying by 1/4. So I know my increments are pi over 8. So I'm going to go pi over 8, 2 pi over 8, 3 pi over 8, 4 pi over 8. We can keep going. 5 pi over 8, 6 pi over 8, and so on. Negative pi over 8. This simplifies to be pi over 4. This to be pi over 2. This to be 3 pi over 4. So we get negative pi over 4, negative 3 pi over 8, negative pi over 2, negative 5 pi over 8, and negative 3 pi over 2, or 3 pi over 4. Okay, and then cosine function, or sorry, sine, it's going to go up to 1 and down to negative 1. The amplitude hasn't changed, and sine starts at 0, goes up, 0, down, 0, up, 0. So here I have a cycle and a half. Down, 0, up, 0, oops, 0, down, 0. Okay, and that's what that should look like. What is the period of the function y equals cosine of 8 theta? So remember, period equals 2 pi divided by k, and that's your k there. So period equals 2 pi over 8, which is pi over 4. So that's my period. Below is the graph of this function. Okay, what's the period of this function? Well, here, your k is actually 1/2. So period equals 2 pi over k. Well, 2 pi divided by 1/2 is the same thing as times 2 over 1. So your period's actually 4 pi. And how do I know this? Well, I just use my formula. Period equals 2 pi over k. What's the period of this function? So here, period equals 2 pi over k. In this case, k is 1/3. So period equals 2 pi times 3 over 1, which is 6 pi radians. And how did I get that? Well, I just used my formula. Graph this function. Remember to find your increments by dividing the period into 4 parts, then label the x-axis. Okay. So first of all, the period here. Period equals 2 pi divided by k. So it's 2 pi times 3, which is 6 pi. Now my increments, I'm going to take my period, I'm going to divide it into 4 parts. So 6 pi divided by 4, which gives me 3 pi over 2. So I'm going to be numbering by 3 pi over 2. So I've got 3 pi over 2. If I add another 3 pi over 2, now I'm at 6 pi over 2, and then 9 pi over 2, and then 12 pi over 2. I'm just going to do one cycle. And here it's the negatives. 6 pi over 2 simplifies to be 3 pi. 12 pi over 2 simplifies to be 6 pi. And notice that one full cycle is 1 period, and our period was 6 pi. So that works out. Negative 3 pi, negative 9 pi over 2, and then negative 6 pi. Okay, amplitude. The amplitude hasn't changed, so my amplitude is just 1, and then it goes down to negative 1. Cosine starts up here at 1, goes down to 0, negative 1, 0, positive 1, and so on. And so here I have 2 full cycles of the cosine graph. And notice the only thing that's changed is my increments because the periods changed. The period here is 6 pi instead of the normal 2 pi. All right, coming to a close, hopefully. Number 18, what's the period of the function y equals cosine 10 pi? Period equals 2 pi over k, so here it's 2 pi over 10. So your period is pi over 5. We just used our formula. Graph the function y equals cosine pi over, or theta over 3. And do we just do this one? Yes. Okay, skip number 19. Skip. It's the same as the one above. All right, write the equation of a cosine function that has a period of 12 pi. So remember that our formula is that period equals 2 pi over k. K is that value in front. Well, we don't know the k here. Here we know the period. So I'm going to say 12 pi equals 2 pi over k. I'm going to solve for k. So times k, cancel. I get 12 pi times k equals 2 pi. Divide by 12 pi. Divide by 12 pi. We get that k equals pi's cancel, so 1 over 6. So my function would be y equals cosine of theta over 6. Okay, because remember this is really 1 over 6 theta, so my k is 1 over 6. Write the equation of a sine function that's the period of 2 pi over 7. So period equals 2 pi over k, so 2 pi equals 2 pi over 7 equals 2 pi over k. Solve. K's cancel. K times 2 pi over 7 equals 2 pi. To cancel, multiply by the reciprocal. 7, 2 pi. Cancel, 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 cancel. K equals these cancel. K equals 7. So your function would be y equals sine of 7 theta. And that's the end. So if you're kind of recapping here, I'll put this on the bottom. Summary. So this is the general form of a sine or cosine function. Your amplitude always equals the absolute value of that number out front. And your period always equals 2 pi